It's 3.3, help with charts, graphs, and calculating energy. So you're going to be given a picture or a problem, and you need to calculate or identify the energy, velocity, mass, and or height. So in problem number 1, you are given a rock is thrown up at 4.3 meters per second. So notice that the diagram is already over here. A is going its fastest, it's just left the ground or your hand or whatever. B is going a little slower, but it's higher. C is going even slower, but it's higher. And D is at its highest point. So step A says draw that energy bar graph. So in order to do that, we're actually going to insert a table. And I'm going to insert an 8-column, 6-row table. Okay, so this is at position A. This will be position B, position C, and position D. And the reason I did that is so that I can identify all the kinds of energy in this diagram. So I have, remember, you're looking for all 4, but in this one, you only have EG and EK. Okay? I'll do another one that has all more of them. So this is EG, potential, right? EK, EG, EK, EG, EK, EG, and EK. And I'm going to actually spread these out just a tad so as to not have my little rounding error down there at the bottom. Okay. All right, so in order to make a bar graph, we're going to color in we're going to shade in the sections. So A is all kinetic. So looking at these 4, I can shade them as being all kinetic. And maybe it would help if I color code the bar graph. So I'm going to do that. So if A is all kinetic because it's going its fastest, because that's what the arrow means, B would probably be halfway up, but it's also still moving. So B might have 2 that are kinetic and maybe 2 that are potential. That does make it easier to see. C, position C, is slowing down, so we have less EK, and it's higher, so we have more EG. So maybe I have 3 blocks of EG and only 1 block of EK. And then position D, it's at its highest point, it's not moving, so therefore I'm going to have all 4 blocks of EG. Okay, so that's your energy bar graph. All EK, half and half, more EG, all EG. Okay, so then part B says, what is the energy equation? Well, remember, the energy equation is just what you are, the energy equation is what kind of energy you have and its location. So we have EKA is equal to EGB plus EKB is equal to EGC plus EKC is equal to EGD. Okay. Part C asks, what is the amount of energy at position A? So part C is EK at A. We need the energy, the kinetic energy formula, which is 1/2 mv squared, which will be equal to 0.5 times 2, that's your mass, times 4.3 squared. And if you grab your handy dandy calculator, that will equal 18.49 joules of energy. 18.49 joules of energy. Part D asked what was, how much did we have at D, right? What is the amount of energy at D? Well, I don't have to know anything other than one of the other positions because the EK at A has to equal the EG at D, came from the energy equation. So the EG at D is equal to 18.49 joules. Part E of this problem said, what is the height of D? So on your formula sheet, your equation alternative, y is equal to EG divided by m divided by g, which would be 18.49 divided by 2 divided by 9.8 on planet Earth. And again, grabbing your handy dandy calculator, you should have 0.94 meters. The rock only went up 0.94 meters. It's not even a whole meter. Hope this helps a little bit. We're going to do another problem in the next video. Thanks.